Hey there guys, here we are going through a couple more variable acceleration exam questions for AS level maths, mechanics, kinematics. Let's go. Okay then, first up, a particle P is moving along the x-axis at time t seconds, where t is greater than or equal to 0. The displacement x meters of P from the origin O is given by x equals 1/2 t squared times t squared minus 2t add 1. Part A. Find the times when P is instantaneously at rest. So that means we want to find the times when P isn't moving. So, in other words, we want velocity equal to 0. Okay, now we know velocity is the derivative of displacement. So, V is dx by dt. Now, first of all, I'm going to expand x. So, x is 1/2 t to the power 4 t to the power 4 over 2. And then we got minus 2t times t squared over 2. So that's going to be minus t cubed. And then we're going to have plus 1/2 t squared. Okay, now, as I said, the velocity is dx by dt. Now that then is going to be 2t cubed minus 3t squared add t. Okay, now we want that equal to 0. And then we're going to solve it for t. So, 2t cubed minus 3t squared at t is equal to 0. Now we can factorize this. First of all, 2t, lots of 2t squared, minus 3t, add 1, and then we can factorize the quadratic part 2. 2t minus 1 times t minus 1. Okay, now that then tells us t is 0, 1/2, and 1. Okay, then part B wants us to find the total distance travelled by P in the time interval t greater than or equal to 0, less than or equal to 2. Okay, distance, not displacement. So, what we should do first of all is check where the particle started. So substitute t equals 0 into x. Now, very nicely, we get 0. So the particle did start at O. Okay, so we then know particle starts to move. It then stops at t equals 1/2. And then it moves again until t equals 1. And then it moves again. So what we need to do is find the displacements at t is 1/2, 1 and 2. So when t is 1/2, x is 1/32. Make sure you get the same. So up to there, the particle has travelled 1/32th of a metre. Next, the particle then stops at t equals 1. Now, t equals 1 gives us x is equal to 0. Now, what this means then, the particle has moved 1/32th of a metre away from the origin, and then it's moved back. So at the moment, the particle has gone 1/32th, add 1/32th. So at the moment, that's our running count. Now the last one we need to calculate is when t is 2. Now t equals 2 will give us x is equal to 2. So the total distance is those three added together. So that's going to give us 2 add 1/16. So we can just write it as 2 and 1/16 metres. Okay, then for part C, we want to show that B will never move along the negative x-axis, so its displacement will always be positive. Okay, so the way that we're going to do that is by factorising x. So x can be written as t squared over 2, or actually let's do it as 1/2 t squared, and now the other quadratic factorises to t minus 1 squared. Now this then is a square number, which can never be negative. Therefore, x is always greater than or equal to 0. Given question 2, a bird leaves its nest at time t equals 0 for a short flight in a straight line. The bird then returns to its nest. bird is modelled as a particle moving in a straight horizontal line. The distance s meters of the bird from its nest at time t seconds is given by s is 1/10 t to the power 4 minus 20 t cubed add 100 t squared for t greater than or equal to 0, less than or equal to 10. Part A, not very clear, wants us to explain the restriction t greater than or equal to 0, less than or equal to 10. Okay then, so again, not very clear. A good way to start this would be to sub in the limits. So t is 0, t is 10, just to see what happens. So, if we do that, we get s of 0 is 0. Now really, we knew that because the bird starts at its nest. Now let's do it with 10. So s of 10 you should also get as 0. Again, not really telling us anything we didn't know because we know the bird flies back to its nest. Okay, so let's look at the displacement expression a bit more closely. So there's a common factor of t squared running through it. So we could write it as s is equal to t squared over 10 times t squared minus 20t add 100. Now, very similarly to the last question, we can write that as t squared over 10 times t minus 10 squared. So this is again a square number. Well, 1/10 of a square number. So that tells us then that s is always greater than or equal to 0 for t between 0 and 10 seconds, so its displacement is never negative. Okay, then part B, we want to find the distance of the bird when it first comes to instantaneous arrest. So what's going on? The bird leaves its nest and then at some point it turns around to fly back to its nest. So we want to find its turning point. So at this point, velocity is equal to 0. So we want v equal to 0. Now, velocity is ds by dt so that's going to give us, we can keep the 1/10 on the outside. Now on the inside, we're going to get 4t cubed minus 60t squared add 200t. Okay, now we want that to equal 0. So, okay, so first thing we can do is multiply through by 10 to get rid of that. So then we got 14 cubed minus 60t squared plus 200t is equal to 0. Now we can also divide through by 4, so we get t cubed minus 15t squared plus 50t is equal to 0. Now we can factorise this. So we get t times t minus 5 times t minus 10 is equal to 0. Now that tells us the times when the velocity is equal to 0. We already knew 0 and 10, so the one we're interested in is t equals 5. Now we want the distance of the bird from the nest at this time. So now we put t equals 5 into s. So s of 5 now make sure you can get this. You should get 62.5. And always remember your units, that's meters. Okay then guys, that's it for this set. Really hope it's helped. Remember to put any requests for topics that you want covered like this in a comment down below. For now, take it easy, take care.